Okay, so welcome to the second part. Now, in the first part, we actually defined the basics of sets and what a relation is, and we took an example where we took a set of days, Monday, Wednesday, Friday, a set of TV series, and the relation that we tried to define is, now let's name this relation as R. The relation that we tried to define is when or which particular day I'll watch a particular TV series, and we listed out certain possibilities. Like in the first possibility, Monday Flash, Wednesday Gotham, Friday Daredevil, and in the second possibility it's a different one, or the third possibility. Now we saw that these different possibilities are elements that can be present in the relation, right? So when you define when I wanted to watch a particular TV series as a relation, you can give this as an answer, or you can give this as an answer, or you can give this as an answer. So we saw that this looks familiar, this looks similar to what we call as a Cartesian product, right? So what is a Cartesian product? Now the Cartesian product between two sets, let's take an example and explain it. Now let's take set A as 1, 2 and set B as A, B. Now what is the Cartesian product A cross B? Now A cross B is the mathematical way of representing the Cartesian product between two sets, right? So A cross B is nothing but a Cartesian product between two sets is nothing but a set of ordered pairs. Now that sounds unfamiliar, right? So a set of ordered pairs. So what does that mean? Now a Cartesian product is nothing but a set of combinations of the elements that are present in the two sets. When the Cartesian product is between two sets, it is a set of combinations of the elements that are present in the two sets. For example, 1, A, 1, B, 2, A, 2, B. Now this set is called the Cartesian product A cross B. Now once again you can see that this Cartesian product again looks familiar. It looks like what you define as the combination, permutation, that kind of a concept, right? So it is similar but with a different twist. That is, what is a combination of elements? When you say a combination in a combinatorial perspective, when you define the combination or the permutation between the different objects, when you define the combination, it is actually the selection or the different methods of selection of the different objects, right? And the permutation is nothing but the different ways of arranging the different objects. Now here, if you see, it is actually a combination of the elements that are present. You're taking one, combining it once with A and once with B, taking two, combining it with A and B. But the ordering also matters in that when you say A cross B, the first element in this component, now I'll define what this component actually is. Now in this first component, the first element belongs to the first set, the second element belongs to the second set. Similarly here, first element to the first set, second element to the second set. So the ordering matters when you define a Cartesian product. Now what is this one single element called? Now, this is called a two-tuple. Okay, so that way a Cartesian product is nothing but a set of ordered n tuples. Okay, so now once again there's a different term here. What is an n tuple, or what is a two tuple for that matter, right? So an n tuple is nothing but, okay, it is a sequence of n objects. Say when you it is nothing but a sequence of n objects, a list of n objects, like 1, 2, 3. When you say up to 100, this is a 100 tuple. Or when you say a set of points, right, on the 2D plane, when you say 2, 5, this is a two tuple. Or if you remember, this is also called as the ordered pair. Sorry, yeah. So an n tuple is nothing but a sequence, or it is a list of n objects where the ith component will belong to the ith set that defines the set of all those objects, right? So a Cartesian product, once again, is a set of ordered n tuples, and that the ordering matters. As I said, the ith component of that n tuple belongs to the ith set that you're defining. So A cross B is nothing but a set of ordered 2 tuples. Okay, so how is a Cartesian product related to a set? Now related to a relation. We saw that the possible candidates for this particular relation, when you take the first answer to this relation, we saw this is nothing but a collection of 2 tuples. Monday flashed, Wednesday Gotham, Friday DD. You can also put it more specifically, right, please? Right? So this is an answer to this relation. When you define a relation between these 2 sets, this is one of the possible answers, and this is nothing but a collection of 2 tuples. This is also a collection of 2 tuples, and this is also a collection of 2 tuples. So any 3 of these, or when you can possibly define more answers to this particular relation, right? So what is a relation now? Is a relation equal to the Cartesian product? It is, but it is not always equal to the Cartesian product of 2 sets. You can define it in this way. A relation is a subset of the Cartesian product between the sets. Okay. So a relation is nothing but a subset of the Cartesian product. So why do you call it a subset? Now, in this previous example, we saw that there were 3 different answers. And there can be more different answers as well. So when you say you want to watch Monday Gotham, Wednesday Daredevil, and Friday Flash, that forms a different set of elements, right? So a Cartesian product between the 2 sets, that is a set of days and a set of TV series, will include 9 different, it will include this. So this Cartesian product is going to include 9 2 tuples, right? But when you want an answer to this relation, it can include all those 9 2 tuples, or it can include a subset of those 9 different 2 tuples. So a relation is a subset of the Cartesian product between the sets. Okay. Now let's give some mathematical notation. So a Cartesian product, let me write it like this: a Cartesian product is mathematically defined like this. Okay, it's not a big deal. You know that the Cartesian product is represented using the cross symbol, right? And A is nothing but the set that we are considering, and I is equal to 1 to n. It's just the subscript that is given to the different sets. So this actually means A1 cross A2 cross A3 cross AN, which means there are n different sets which are named A1, A2, A3 up to AN, and you are taking the Cartesian product among or between these n different sets, and that in shorthand is represented like this. Now if this is represented as this, how is the relation represented? Sorry about my pen. Now we said that the relation is a subset, right? So a relation, let's say R, is nothing but a subset of the Cartesian product. Okay, so this is a subset, but you see that it is a complete subset. That is, it has total containment, which means now R can be equal to the Cartesian product, or it can be a subset, a proper subset of the Cartesian product. This is how a relation is represented.